So here's our situation. 2-5, I'll grade the 2-5 quiz, but I'll talk through what was on it. Nothing tomorrow gets repeated. The 2-6 quiz is just straight out of the reading, all new all the time, 100% new. That's the bad news. The good news is, I gave you a copy of the quiz. So it says practice at the top for you to read, fill in, study. You should be able to dominate that one because you see exactly what the quiz is. You're just going to have to read the section to figure out what the words are, fill them in, and be ready for that. We'll put 2-5 and 2-6 terms together in a future quiz down the line, a day or more than a day away, but we'll worry about that in a future setting. Homework is going to be on page 34. If you have your book already open, go to 34 with it. We'll talk about page 34 in a minute and just sort of preview the ideas. But here's our setup. From what you read in 2-5, they're basically describing to you a number line. That's all this is. So they use some big words, some small words, some other words, but basically they're just describing to you a number line. So the first postulate, what was it called, the first postulate from the quiz? It's the ruler postulate. So number one was the ruler postulate. The ruler postulate is telling you three things. If I'm going to refer to points, what do I mean? Am I looking at the letters or the numbers if I'm talking about points? Letters. Always points will be named by letters. The numbers had another name that made the quiz toward the middle. What were the numbers called for these things? C word. Coordinates. So 0 is a coordinate for the point D. 2 is a coordinate for the point F. What they said in the ruler postulate is that every point has to have a if I pick a point, you should be able to tell me a number. And if I tell you a number, you should be able to tell me a letter, a point. That was the first two sentences of the ruler postulate. For every point there's a number, for every number there's a point. Whether I'm pointing at this number line or that number line, if I say like I'm looking at 3, well you're looking at G, hopefully with me. Then the third part of that was to find the distance, like on this, if I want the distance from F to H. So here's F, here's H. What's the distance from F to H? 2. How did you do that? Just subtract the coordinates. What's it called in math when you subtract stuff? The answer when you subtract is called difference. Difference was one of the quiz points today. How about if I wanted the distance from H to F?
Still 2.
It's still 2. It's not -2 because there was another blank we filled in maybe today. Absolute value. Absolute value wants to guarantee us positive. So that's going to be the two blanks you filled in off of the ruler postulate were absolute value and difference. Meaning subtract the numbers, but make sure you come up with positives. Yesterday the distance postulate said for every 2 points there corresponds. Somebody finish that. Distance postulate, for any 2 points there corresponds unique positive number. Distances have to be positive. Absolute value will make sure that that happens for you. So if I go distance from B to E, find B, find E, subtract the numbers, or just count how far apart they are if you want to use your fingers. But make sure it's always positive. Distances are always positive. From B to E. Somebody, anybody? Distance from B to E? It's taking way longer than I would expect. Distance from B to E, how far apart are they?
3.
3 squares. 1, 2, 3. That's all we're looking to do. Count the squares. Or you could subtract. If you do -2 subtracting 1, what's that get for you? -3. If you do 1 subtracting -2, minus minus makes plus, turns out to be 3. But distances have to be positive. We're not going to do negative distances. All distances are positive. So that's the ruler postulate. That's the idea of coordinate. This whole thing, a bunch of coordinates all put together, was a 2-word answer that made the quiz. What's that called? Coordinate system. So the coordinate is a number. The coordinate system is the whole thing. Then the other postulate, what was the second postulate called? It's called the ruler placement postulate. Ruler placement postulate says if I want to set myself up with a number line, I can pick any point I want to for my foundational number and just label it and go from there. What number would you expect would first go on any number line, on any coordinate system?
That's from my test.
Yeah. Who's the most important number on the number line? 0. So what the ruler placement postulate tells you is you can walk up to any old line and say, I'm going to make a number line out of this. I'll put 0 wherever I want. I'll put it here. I'll put it there. I'll put it here. Does it really matter where you put it? No. For convenience sake, you might put it toward the middle, but that's not necessary. But the ruler placement postulate's telling you for any line, if you want to, anywhere, put 0 to start. And then you'd have to decide that one of the directions was going to be positive. Most of the time, positive goes right, but does it have to? No, that's just like more commonplace. But ruler placement postulate was just telling you one of the numbers is 0, pick some direction to be positive, and that's how you could create a number line. Again, none of those recycle tomorrow. They'll all recycle someday for a test, but for studying purposes tonight for quiz, all you need to do is read 2-6, fill in that little sheet, study those, and then crush that tomorrow. 2-6 is the only quiz we have. Question about what the words today meant, or question about 2-6, what you're prepping for. Let's look at homework page. If your 30 is started, send me your 30 so I can see that it started. Just prove to me that you're doing what you're supposed to do when you're supposed to do it. And then let's take a brief preview of 35. 35 is the new one for tonight. So 35, we're going to work 1 to 5. 1, we could do a quick kind of rehearsal from the board. So if I say I'm looking at the point E, what is its coordinate? 1. I'm looking at a coordinate of -2. What's the point? B. If you can manage that, you can manage 1. Question about 1. Okay, 2 is just some absolute value math. Just do the subtract first and then zap it with the bars. That's what 2 is. 3, you're going to build yourself a number line based on their instructions. So like 3A, you find where 3 is and you'd put a B on it. They slightly disguised 3, because how is 3 slightly disguised on the number line? Where is 3 on the number line? $35, somebody? Where is 3? Yeah, it's the square root of 9. They slightly disguised. Square root of 9 is 3. So you'd label a B on there. But they just want you to copy that number line down and then put a bunch of letters in the right spots. You are going to have to add on some new locations. Like later you can see there's a square root of 12. There isn't already marked a square root of 12. You're just going to have to put that in the right spot, which would go right between the 9 and the 16. Let's do a little bit of 4. 4A, they're asking you to find the distance from A to C. That's like what we did on the board a couple minutes ago. Whenever I commented, it seemed like it was taking me way longer than I thought it was going to for us to come up with this 3. So for 4A, they're asking you the distance from A to C. So find A. A goes with the number 0. Find C. C goes with 1. So how far apart are they? 1. Just make sure all answers are positive. For D, find P. -3. Find R. -5. How far apart are they? 2. For G, find B. Half. Find H. 9 halves. what are you gonna have to do with all the numbers? Subtract. Subtract gets you 8 halves, but best answer 4. For part J, find D. Root 2, find J.
Root 31.
Root 31, and then what you want to try to do is subtract them. What's the best you can do? If your job is to try to subtract a root 2 with a root 31, what's the best you could do with that?
Root 29.
No, can't do root 29. Roots don't work like regular subtraction. Anybody a theory? What's the best you can do if we're trying to subtract roots and they're not the same kind of roots? Yeah, what subtraction problem?
Root 2 minus root 31.
I would disagree with that one. But that's close. Anybody a theory? Why am I disagreeing with root 2 minus root 31?
2 minus 31.
No. What kind of answer do we demand for distances? Yeah, why do you have to switch it around?
So it's positive.
Has to stay positive. So you want the bigger number first. 4, that's what you're doing. 5, instead of having to look the stuff up on the number line, they're giving you the numbers. Just continue to subtract the numbers. Most of what this whole page is about, find the 2 coordinates, subtract them, make sure you get a positive result for distances. That's what's up with 35. That's it.